So hi everyone, my name is Piotr Betkier, and today I'd like to talk about a topic that is, in my opinion, not much discussed much in the community, but it is still very important. It's about building libraries, especially in the context of building internal tools ecosystems, tools created inside companies, so-called commons. I want to share my views because I've seen multiple approaches in a couple of organizations. And especially right now at Allegro, I'm in a team that, among other things, is responsible for growing such internal tools ecosystem for our microservices-based architecture. And I have a few thoughts about that. So first, we'll shortly discuss a few models of providing shared code inside a company. And then, for the most part, we're going to analyze what makes a library great, what to have in mind when building a library. I hope that after this talk, you'll have many ideas how to enhance your internal tools ecosystem and also how to create successful open source tools. So what's the deal with all these commons? When we create a larger product in our company, for example, a system consisting of multiple interconnected services applications, or maybe we regularly build similar projects, independent projects, but rather similar to each other, we have such situation that we've got a lot of projects, but we have some common code that is, a code that is common among them, and we want to write it once. This often will be some kind of infrastructure code, like enforcing certain logging format, or where do we place our metrics, or maybe just establish way of configuring some external libraries that we chose in our company, or maybe implementation of some internal mechanisms. Now, how not to implement all this from scratch in every application? So from my observations and discussions with others, I can see a couple of approaches. First approach is what I call a Wunder-framework. This is when this is a pattern that appears from time to time in companies, especially larger companies, where a company decides to build its own framework that's going to cover all needs. And every application is going to throw in this framework as a dependency and use it. It doesn't have to be a framework like written from scratch by our brave engineers. It may be just a certain way of configuring some well-known framework, like Spring often plays this role in the Java role. It will be a well-known framework enriched with some bunch of external libraries. And I know this approach quite well because we had such episode in Allegro as well. When we started our microservice revolution 3 years ago, and we started moving from a monolithic 1 million lines of code system to a network of independent services, we needed some base so that our teams could code their services quickly and ensure that these services have consistent mechanisms, that they can talk with each other, and this network of services, is consistent. So we created such framework, such Wunder-framework. It was based on Spring. That was time when Spring Boot was still a toy, so we couldn't use Spring Boot at that time. It consisted of anything you could think of that would be useful for creating a successful microservice. So it had some certain logging format, and these logs were sent to Logstash. It had some, some metrics from Drop Wizard with some certain conventions. It had dynamic properties based on Zookeeper, some end-to-end tests, helpers, and more. Everything you can think of creating a successful microservice, it was there. It was also heavily opinionated, so it made decisions like which REST clients should you use, or what to use to expose your REST APIs. So what a developer had to do, just throw in this framework as a dependency, and he was ready to deliver business value. And indeed, this framework helped these teams to go into production quite quickly, and the framework itself was written quite fast. Developers didn't have to think much which technologies to choose, how to configure them, and everything. They just threw in the dependency and could start coding. But it soon became apparent that this approach has many drawbacks. So every application and every team had its own characteristics, and they wanted to do things a little differently. One size does not fit all. So, for example, if somebody wanted to like they didn't need Zookeeper for dynamic properties. They still had a dependency on Zookeeper, and they still had all the configuration around it. If somebody, say, thought that Jersey client wasn't the best tool and they wanted to use something else, well, they couldn't because everything was so interconnected, coupled with that's Jersey client, and it's you use this client, it's connected with our Discovery service and all that. If you replace it with something else, it doesn't work. So everything was opinionated. You couldn't customize much, and it was also hard to update subsequent versions of this framework because everything was so tightly coupled. There were so many developers using it in a different way. Well, when you were updating to the next version, adding some new features or fixing some bugs, you weren't sure that there is no service somewhere that is going to break after such update. So it was a real pain. Yeah, and perhaps the saddest thing is that even though we put so much effort into this framework, still many teams couldn't use it because it was heavily opinionated. It was based on Spring. If somebody, say, wanted to use Scala for some big data stuff, they wanted to use some Scala-specific frameworks. They didn't want to use Spring and all the Java technologies. So they ended up re-implementing all these mechanisms that we had in this framework from scratch in their services. And of course, they were trying to be compatible, but of course they weren't, because it's not that easy to just be compatible re-implementing stuff. So yeah, that was a problem. So despite serving its original purpose, such framework, one-size-fits-all framework, turned out not to be practical in the long run. And it became apparent that we need something else. And then we modeled our commons a bit differently. Now instead of this one single super framework, we created a family of libraries under a single umbrella. These libraries do one thing. They are independent from each other. They are composable. It's easy to put them in, take them out from the project. And they can be used by anyone running on JVM. And each library adds some functionality that you can throw in, and you can compose such functionalities in your projects. So these libraries cover different areas. So we have a library for service discovery, we have a library for metrics, for logging, tracing, gathering cloud metadata, and many, many more. What is important is that these libraries are independent from each other. You can use them if you want. You can decide not to use them if you want. And these libraries are either some wrappers over some external libraries, like we did with tracing, when we wanted to hide the complexity and have a single way of configuring it, or integrations with our infrastructure API, like the library for reading cloud metadata does. It hides the complexity of API for reading cloud metadata in our environment. Maybe they enforce some conventions, like we do with metrics and things like that. So once again, important thing is that they don't assume any technology stack. The app just needs to run on JVM, and you can use these libraries. But most applications are rather similar still, and most often such common application needs all of these things actually. So it would be tedious to ask developers to throw in all these libraries and configuring them by themselves. It would take a lot of time, and we want to start quickly with our services. So we decided to create a framework as well, but it's the framework with a completely different philosophy. It's a starter for Spring Boot, and all it does, it just makes the common case bootstrapping. It's throwing in all these libraries that I talked before, and it configures them in some default way. That's all it does. It contains only glue code, no logic in this framework. You can easily disable certain features if you want, using some flags, or you can override default configuration. Here, this annotation conditional on missing a bean from Spring Boot is very, very useful for writing such frameworks. Yeah, and as I said, no logic, it's just glue code. So if somebody doesn't like our framework, say these Scala guys, or I don't know, some people writing super performant servers on raw, some raw server, then they don't want to use Spring, they don't have to. They can still use these libraries independently from the framework. So yeah, so all the goodies are in the libraries. So this approach works for around 2 years in our company, and because we had to build so many libraries, it showed us traits of a successful library. And this is what I would like to talk to you for the next couple of minutes. So first principle when writing a library is that this library should have an owner or a group of, it doesn't have to be a single person, it can be a group of people, but there has to be somebody who is responsible for this library. Well, library is a product, so it needs someone with a vision who is responsible for that. It ensures that all the other principles that I will talk about are obeyed. I don't believe in tools just, maintaining by themselves, by the self-organizing, developers self-organizing and maintaining together some piece of code. Everywhere, it turns out everywhere where I worked, it turned out to be such library turned out to be just a sink for all the code that any developer thought that may be useful for somebody, and such library quickly became just a big ball of code, unusable, and certainly not following the principles that I will talk about. So yeah, so an owner is a very important thing. And then when we have an owner, second thing to remember is such libraries should do ideally one thing and do it well. So this comes from this Unix philosophy. The reason why Unix ecosystem was so successful is that they had, the processing was they had small composable tools, and when you compose those tools, you could achieve great results, as opposed to having a single tool that you would configure very verbosely. So this also means that we want to have a family of libraries, not a huge library called X commons, where under X you substitute the name of your company or your department, right? You want to have single-purpose tools. Probably the hardest thing is how to define the scope of such library. I see it like, basically we have a space of all the technical aspects that we can think of, and what we want to do is we want to pick a subspace that is, loosely coupled with other spaces and cohesive, so basically just object-oriented design here, but on a level of defining the scope of a library. We sometimes use a single sentence rule, where if we think of a library, then it should be easy to describe it using a single sentence. So for example, we can have a library for a service discovery where an application starts, it's going to register itself in some global registry of services. It's going to register its instance in some global registry under some name, and when it's shutting down, it's going to unregister, and we are able to ask this registry what are the instances for some name. So it seems like a good scope for a library. But now, if we, for example, wanted to add some metrics from how this, querying this discovery service behaves, then, one could think of, publishing these metrics somewhere for some global storage to have some dashboards. Well, that certainly is not a single scope when we also think about sending metrics somewhere and drawing some dashboards and all this. This seems like a second responsibility, something that should be done in a completely different library, and maybe discovery service library should only publish these statistics using some on some interface on some API. So doing one thing and also being technology agnostic. So being technology agnostic means making as little assumptions about the technology stack of your users as possible. So for example, when we have this discovery service library that I talked about, we could assume that everybody is using Spring in our company, as maybe it seems like that. So we could organize our discovery in a way that when you want to use it, it's of course configured in Spring, so maybe you just import some configuration, or maybe when using Spring Boot, you just use auto configuration, and yeah, you expect that somebody has a certain property on in their context, and everything just automatically works. This could be one way of organizing such library, but this is a huge no-no because it limits potential adopters, because maybe it seems right now that everybody is using Spring in your company, but sooner or later somebody will want to use a discovery also in their other applications, like I mentioned Scala guys doing some things in Spray, or maybe just somebody using some script in Groovy. He wants to query discovery service using some API, and you cannot just assume that everybody is using Spring, even though it may be very popular in a company, or maybe right now everybody is using Spring, but it may not be true in the future. If you do such things, then you drive technology decisions of your users, and it should be the other way around, right? So what you want to do is you want to create an agnostic core. So the core of the library should be completely agnostic. So that could be a way of configuring such discovery client. You have a builder, okay? You provide some properties explicitly, and then you say build, and that's how a discovery client is built. I don't care how it's done in your technology stack. I don't care how you create things. Do you register them as some beans, or do you do it differently? You have to handle it. I know how to. I can show you how to build a discovery client. You know how to put it in your context. So, for example, this means that if we have such a discovery client, then we expose some methods for registering at startup, for shutting down, unregistering and shutting down, and finding instances when processing requests. But that's what I provide, technology agnostic. Now, if you're using Spring, you know how to register some application listener. You know how to register some shutdown hooks. So it's your responsibility. I don't care. I just tell you what can be done. You can say how it's done in your technology. So so first of all, it's going to be universal, and second of all, it's going to be much easier to test for me, because such library, technology agnostic, I don't have to think about all the quirks of Spring. It's just super simple. So how to achieve all this? Because sometimes we cannot just leave people with these totally agnostic libraries, because perhaps this integration of Spring, setting up these shutdown hooks and all that, perhaps it's rather complicated, or maybe it's just some code that would be duplicated in every single service using Spring. So we want to provide some help with that. But what we do is we have multiple modules. So we have a core module that is technology agnostics, and we are also providing some other modules that are helping with integrating this technology agnostic core in certain technologies. So we have, for example, Discovery Spring. It uses Discovery core, it has it as a dependency, and adds some classes which help you integrate this thing with Spring. Maybe we have also Discovery, OK HTTP, which helps provide some filter, some interceptor for OK HTTP to change a service name to a list of instances, I don't know. So this is one way, and we are heavily depending on this. Most of our libraries look like that. What you can also do is you can keep all your classes in a single module if you don't want to have all this hassle of maintaining multi-artifact projects. But you can separate packages of your project in a way that you have some package with core, which is technology agnostic, and you also have some certain packages with integrations with different technology stacks. So maybe you have a package with integration Spring, where you have classes for Spring that somebody can throw into their code, But the dependency on Spring in this project is marked as provided in Maven or compile only in Gradle. So it means that the Spring dependency or OKHTTP dependency doesn't, isn't added to your POM as a dependency that somebody will have to throw in. It won't be a transitive dependency that is pulled together with the library. It's more like if you want to use integration Spring classes, we say in documentation that you need to have Spring on your class path. Okay. And being technology agnostic is also connected with having minimal dependencies. That's one of the reasons. Ideally, libraries should have no dependencies. That's the best case. Why don't we need it? Well, first of all, if you throw in some transitive dependencies, like Guava is a good example. Everybody would like to have Guava in their code, right? So if you, in your library, declares Guava as dependency, and your service, your user service also declares Guava, then there will be, and they have different versions. For example, there have to be some dependency resolution. So, for example, if you use Guava 19 and your user service uses Guava 17, then, for example, his Guava 17 would have to be updated to version 19. Perhaps your user service is not working with Guava 19 because maybe in such version some methods were removed. So you're impacting your user's class path by throwing in dependencies because they have to be resolved to a single version. Also during keynote, we talked about this case of left pad gate, where some event caused one dependency to be removed from a central registry of packages. And it's maybe a bit funny, hilarious, because this dependency, it was just a couple of lines of code, like you could give to somebody during a warm-up, during a technical interview. But it was a dependency that was used by so many important frameworks in the Node.js community that when this library went down, all the important frameworks could also not build, and in the end, the whole JavaScript world was off for around 1 day because they couldn't build their projects. So each dependency carries a risk, and perhaps libraries missing from package manager are not that common, but still, problems of your dependencies become problems of your own. If somebody changes API in a weird way, or he pulls in some transitive dependency, your users will experience that. So what can we do about it? One thing we can do about it is, for example, use a mantra from Go proverbs, specify a couple of rules. And one of the principles that they say is that a little copying is better than a little dependency. So if you, for example, are considering throwing Guava as a dependency of your library because you just need to have this, small piece of code, because in Guava, for example, joining string is so much easier, then, well, don't. Just, either copy their part of their code into your internal util class that you are going to use, or maybe, just leave with that and write your verbose code in your library, but avoid throwing in external dependencies. Another thing you can do is you can also use this pattern of shading, where you are, instead of declaring some dependencies as transitive dependencies for your library, you are incorporating these libraries as part of your artifact. So you are changing package names. It's also called repackaging. So you are changing package names of certain library, and after repackaging it, for example, whole Google Guava is under a different package name, and there are no more dependency clashes, right, with your users' libraries. But maybe questions in the end, okay? So this also introduces some problems. I don't want to talk about it much, but when you use some things like class path scanning or instance of, there may be some problems with such approach. As, for example, Elasticsearch is now moving from shading back to pulling in dependencies. We don't use that much, but I'm just saying about it because it may be useful for you. Okay, and I don't say that you can never throw in dependencies. I just want to say that you should consider it, consider the costs, and if you can, avoid it. Sometimes you cannot avoid it, sometimes you do throw in dependencies, we do it as well, but we always consider the costs of doing it. Okay, and also what I would like to tell you is that you should use the lowest common denominator language for building your libraries. It's connected to not throwing in dependencies. What I mean is, for example, I like Groovy for writing my services, but I wouldn't write my libraries in Groovy because that would mean that I have to throw in Groovy runtime library on the class path of my users, and my users may not be happy with that. So, same with Scala. Like Swagger, like for a year ago, Swagger was written in Scala, so everybody using Swagger had to have, had a Scala with some version on their class path suddenly, and now they've written it into Java. So basically, your libraries should not have any dependencies. So it also means you don't want to use some esoteric languages. You want to use the lowest common denominator, which is Java on JVM. Next thing, we would like our libraries to have clear entry points, meaning be clear where the whole API of your library is. Don't ask developers to search through entire code base. So for example, make a builder that creates an object that you want, and this builder could be the single point of entry of initializing your library. Like here, maybe we have a discovery client, and you say builder, and then builder drives you with all the possibilities, all the options for building such discovery client. For example, we discovered that we can provide some custom strategy for load balancing when we have this list of instances, choosing which instance to send requests to. And you know that you have such option because that's what you see in this builder, okay? You also know what you can do with Discovery Client, because once you have your instance, you have a list of possibilities in the Discovery Client class, right? You have a list of methods, and it's clear what can be done and what are the entry points of your library. Also remember that inheritance is one of entry points. So for example, we could have designed our library in a way that you inherit from some Discovery Client base class, and then if you want to change implementation of load balancing, you override some method for picking instance from a list of instances. We could have done it, but we don't want to do it because now this method becomes an entry point. And if we change this superclass, if we change Discovery Client, then we may break our inherited subclasses. Our users' subclasses may be broken because they may make assumptions about contract of this pick instance method that we haven't thought of. They just looked at the code of the superclass, and this may change. So avoid inheritance where you can. Using composition, like we had in our previous example, is much more explicit and much safer. Also, be aware that if you ask users to inherit from your base class, then your library code is suddenly all over the user services code base. For example, if you write some ORM tool and you require your users to extend from some base model in order for this mapping to work, or maybe you have some exception mapping tool and you require your users to extend from a certain base exception. Well, it means that now your classes are used all over the service code of your client. And it means that it's going to be much harder for them to resign from using your library, to throw it away, and much harder to test their code, because it's going to have dependencies on your classes. Well, that said, if you need to use inheritance because that's what you think would be useful, then be explicit about it. So call your classes like abstract something or base something. So say explicitly that this is a class that should be inherited from, and these are the methods that you can override, and that's the contract that's not going to change during subsequent releases. So I'm saying all this about entry points because what I want to stress is that entry points are public API, and this public API is a contract that needs to be maintained between releases. And I see it like, well, you have your library code, okay? It's somewhere here, this space of all the code in some users space, okay? You have your library code, okay? This is some code of your service, some user service, and there are some entry points, some points of contact, and they build some surface of contact between your library and the user's code. And if this surface is small, then you can do whatever you want with your library. You can change some mechanisms, refactor it, you can do a lot of things, evolve it as you want. But if your surface is large, there are many entry points, then you don't have much possibilities, because you have to maintain this surface, these contact points, and there is not much you can do anymore with your library. So having clear entry points is very important. Now, it's important because it's hard to change public APIs. Once you publish something, it's hard to change it. Maybe there is this quote that public APIs are forever, or that you have one chance to get them right. Perhaps that's saying too much, because you can always break backwards compatibility if you want. It's just hard to do it. Inside your company, maybe if you are doing some internal library, well, perhaps you can do it. I mean, you could send some emails to your clients and say, well, sorry, but we are breaking this, and yeah, that's the migration guide, and yeah, sorry for that, but yeah, life. But you can do it, from time to time and frustrate your clients. It's much harder to do in an open source library, because you don't have access to all your clients. Basically, some clients won't migrate for a very long time, maybe never, and each such incompatible change is causing you to lose trust, and people will eventually stop using your tool if they have to change their code every time they need to bump version. So keeping compatibility is important, and how to do it? Well, basically you need to keep the old API working, even though you add some mechanisms or change some mechanisms. So you keep the old API, annotate with deprecated annotation, you specify how you should migrate, what's the migration path, which methods should you use now. And yeah, you leave them for a couple of releases. With enough creativity, you can sometimes hide the fact that mechanisms changed under the hood and make the old API basically just delegate to some new API that you've just written. So not necessarily you will have to support both mechanisms. Maybe you will have to support just both APIs, but the previous mechanisms will just delegate to some to the new mechanism. Also recognize that it's hard to change protocols. What are protocols? Protocols is something more than just API, because API is something that your users will use in their service, and a protocol is some format you define for communicating between the multiple services, for example. So I mean things like, for example, that our services expose a health check on an endpoint called status health, or that our services exchange some correlation ID header, and it's called like that, and it has this format, and all services exchange this header. It's very hard to change such things, because if you change this, incompatibly, then, for example, you have two services exchanging information via some well-defined header. If one service, starts using different protocol, they cannot communicate. You have a breaking point. Also, such protocols are things that are implemented not only by you. Perhaps, for example, this health check endpoint, it's going to, to be used by some monitoring tools as well, and maybe implemented in some other languages, in some totally different tools. Maybe not even you knowing about it, that somebody started being compatible with this protocol. So it's very hard to change protocols. You need to think them right. Think about HTTP protocol, for example. How long are we staying with this, specification one that was, released in the early 90s? We cannot change that, because we would break the whole internet, right? So how do you achieve? How do you make your APIs not being broken in subsequent releases? Well, you need to have your APIs private by default. So whenever you don't have to expose something, don't expose it. Only expose something when you really have a use case, when you really find somebody that needs this thing to be public. And if you're writing some new mechanism, then perhaps first create some draft, proof of concept, invite some clients to see if that's what they would like to use. Maybe first release things with as an incubating feature, say that it's a beta API and it can change in the future. So all this just to do the API in a way that is, this API should be right just from start, so that you don't have to change it later, especially if it's a protocol. Okay, next thing. I've had this situation where I searched for some library, and this library had this headline on the beginning of their README, that this library is no longer supported. Community destroyed my project. Like, what? Community destroyed my project? Yeah, because this maintainer said that, well, he had this very nice library, so it was very popular, so many people were using it, and people were asking for changes, they were throwing in pull requests. So basically he was accepting everything because he was so happy, and it turned out that the library was no longer useful, because it was just a huge ball of APIs, and it was very hard to do anything with it anymore. So recognize that you don't have to accept everything. Just because it's a common library doesn't mean anybody can contribute, anybody can throw in a code. When a user comes with a problem, they usually come with a ready solution, like, we have such method, we need a third parameter to this method, so it will behave like that, okay? Maybe sometimes even they will just provide you with pull request ready to merge, but don't merge it yet. You need to find true requirements, why the user needed this third parameter, what was the problem? Take a step back and think about this problem. Perhaps what this user wants to do is a part of some more general solution. Perhaps it should be a completely new mechanism, maybe a new area, a new library even. Or maybe we often have these situations where we talk with the user, and it turns out that he actually doesn't need the thing that he thought he needs, because, for example, he can do it in a different way, not needing this third parameter. Or maybe what he wants to do is actually just some hack, and we just need to explain to him that it's wrong, what he's trying to do is wrong, and he should follow a different path. So think about your clients, think about their true requirements, and also when you're about to add some API, you need to think about the trade-off between flexibility and ease of change. ease of change. Flexibility means that your library will be able to do anything. It will be super generic. It's not what we want. We want our library to be easy to change because requirements are going to change. We're going to discover more about the domain. And we want our library to be able to evolve year after year. So a way to keep your library easy to change is to defer making decisions to the very last moment, being a lazy perfectionist. Just if you want to add some new API, don't add the whole big spectrum of possibilities. Just make a small step in a certain direction and see how it works out. This will help you slow down the inevitable increase of complexity and help you move forward for a longer time. To make decisions about APIs, about mechanisms, you need real use cases, multiple use cases better. So work with the clients, and if there is no client for some mechanism, for some API, then just don't add it yet. And now two more points. So library should contain no magic. So there should be no magic constructs in the library code. I don't mean only unclean code, but also like some weird constructs like reflection inside or things like that. What I'm saying is true for service code, business code as well, of course, but it's especially important for library code because library code is something that will be read by everybody in the community. People will be reading code to learn how things work. They are going to debug through this code when they are looking for problems, and they will be contributing to this code. So it's not just one team, it's a whole organization. So this code should be very easy. So one of the sub-points here is, for example, don't throw in things like Lombok to your library because this is just magic. You're manipulating bytecode during compile time. In order to understand it, you need to understand your library. You need to understand how Lombok works, what it does. You need to have some plugin for your IDEs to be able to debug through such code and develop in this environment. And all this just to be able to generate a few getters. I mean, that's not worth the cost. So if you want to use Lombok in your services, that's okay. But in library code, you should be clean. And writing getters is not a hotspot in developers, toolmakers' job. Toolmakers spend most of the time on other things, not generating getters. So that's a false optimization. So make your life easier and Lombok your libraries. And the last point that I would like to cover is making our libraries harmless. What I mean about making libraries harmless, your libraries should, for example, have reasonable defaults. If you provide some properties so users can change these properties, be sure to make these defaults reasonable, like defaults that could be put into production and not break anybody. We all know, for example, that our default REST clients like REST template or Jersey client, by default, they, for example, don't define timeouts. I mean, they use system default timeouts, which could be very, very long. And how many times did we have some problems on production where all our threads got saturated because somebody didn't define a timeout, right? On communicating with external services. So, have your defaults ready to be put into production. Also, fail fast on silly mistakes. If somebody, sets some property with a value that is not reasonable, it's not going to work well. Fail fast. Say explicitly that it's not okay. Don't wait a couple of minutes where later you will have some problem with state. But that said, remember that when you're doing things automatically, people expect things to just work like magic. They are not aware that there is some decision behind the scenes. So if you make some if you push this, auto configuration, this, magic that things just happen out of the box, if you push it too far, then people will expect things to work and not be aware that there is some decision to be made. Sometimes it's better to be explicit. Maybe it will be less useful for the hackathon level services, but for the real for real purposes, like putting things to production, people will be forced to make the right decision. Also, have in mind that people don't read the documentation too much. They rely on the code, but you still need the documentation because you are going to direct developers to the documentation. Such documentation should also not only have installation guide, some usage guide. It also should say about limitations. What this library doesn't do, what's its vision, what are the alternatives if you don't like the certain decisions that were made about this vision. Be aware that developers are humans, and like humans, they copy code like crazy. If they see code, they expect things to work. They just, needs to do things quickly, so just copy this code into their service. So if you're writing some documentation, be sure that these examples that you show are examples that show ideal usage of your code. This is code that will end up in production, somewhere in some service. So you shouldn't, cut the corners. You shouldn't make things, simplify things just for the sake of documentation. This documentation should show code snippets that are ready to be put into production. If it's hard to use your library and this example would have to be very long, well, perhaps there's something wrong with your API. Okay. These were 9 points that I wanted to share with you that I've come up when growing this libraries ecosystem at Allegro. And what next? So is this approach with family of libraries flawless? It doesn't have any drawbacks? Of course it has. So the biggest drawback is that it takes time for developers to migrate to new mechanisms, because still this common code resides in their services, right? So they need to explicitly update some version of library. If there are a lot of libraries, they have to do a lot of updates, and it takes time, and you need to, sometimes you need to help them. Sometimes you need to, ask them to do it because they would prefer to stick with older version for a long time because they have some different priorities in their project. And still, despite all this effort, if you have some users that are not on the JVM, say some guys writing services in Python for infrastructure, or in Go, or in some different languages that are not JVM based, well, they are still left on their own. They need to re-implement all these mechanisms that you've just implemented in the libraries. They have easy task, perhaps, because they have this reference implementation of yours, but still they have to re-implement all these mechanisms. That's not very good. So what we can do is we can make our environment aware of all these mechanisms. So what we can do is we can try to move the logic from these libraries, from these services, into the environment where the service is run. So, for example, this service discovery thing. How about if the application didn't register itself and unregister itself as part of runtime, but instead it would be deployed in an environment which would by itself register such service and unregister this service when the service goes down. So we could have, for example, some sidecar process, some companion process that is being run along with the service, and it's watching what the service does. If the service is up, its health check says it's okay. Then this process registers this service in the service registry. When the service goes down, then this process checks that the service is no longer up, and it's unregistering this service. So now the responsibility for registering is moved from the service to the environment. Now it's much easier to, for example, change this mechanism, add something to this registry logic, and also all the applications that are exposing some certain health check are able to be registered and unregistered, not only JVM-based services. So you probably cannot move everything from your libraries to the environment, but there are many opportunities there to simplify things for the service. And sometimes you can also maybe extract some code in your library into a technical service that's going to be queried by some REST API, and now the logic resides not in the service of your users, but in a separate technical service that can be updated independently. It's maintained by somebody else, and it's much easier for anybody. It's not possible to do it with anything, with all the logic. It's still, you will have some logic in the service, but whenever you can, it's a good way to go. Okay, so summing up, 3 approaches that I discussed: Wunder-framework, family of libraries, and rich environment. And these are the principles that we've talked about. As you can see, these are actually just good old object-oriented design principles, but here in the context of building libraries, they are much, much more crucial than in business code, because you cannot just refactor things later. If you publish some API, you cannot just refactor all your clients or your code bases. So it's very important to be aware of these principles. So that's all. That's the material that I had for today. Unfortunately, I've eaten all the time for question and answers. So if you want to ask me anything or give feedback, then I will be here in the corridor, and we can discuss it. Thanks.